All right, folks, it's 11 a.m. We're ready to kick off the sixth installment of the Local First meetups. Today, I'm excited to have a wonderful group of speakers. Two of them are the OGs who were day one members and founders. That's James Pierce and Matt. I'm really grateful to have you both continually support and drive our community forward. And we have Skiff folks in the house. Y'all have seen my tweets. I'm a big fan of their entire privacy page, is how every app should be built. So it's no surprise we're going to open up with a product, and I'll hand it over to Jason after doing a quick intro for him. He is the co founder and CTO of Skiff. Today's talk, he'll be discussing about their journey into building a wonderful product across their calendar, mail, pages with an end-to-end encrypted format. And without further ado, I'll hand it over to Jason and Guy.
Thanks so much for the intro. Let me get my screen up. So we will be presenting, obviously, from Skiff. We are a privacy-first suite of productivity products. And today we'll be talking about how we brought local first end-to-end encrypted apps to over 1 million people in the past 14 months. So as mentioned, I'm Jason. I co-founded Skiff about 3 years ago, and I'm the CTO.
Hey, my name is Guy. I'm working with Skiff for the last 2 years. Worked especially on a local first application and building a sync engine for our products.
So I guess the context to really understand, how we built, why we're building Skiff, is really rooted in this observation that our digital lives have honestly become our actual lives today in a really meaningful way. And with that, a lot of things that we take for granted offline just simply don't translate, whether it's freedom, agency, ownership. And so a lot of companies, the way they've approached this problem is they've come up with policies or stances, but those don't really give you much assurances. And Skiff, we've focused on really leveraging technologies like cryptography to bring freedom to the internet and guarantee it in a way that is really enduring. Concretely, that has meant building out this productivity suite. Right now we have 4 products across communication and collaboration. The most popular one is our email product. All of them are end-to-end encrypted. We also have a document collaboration, it's a real-time collaboration product, file storage and drive, and then calendar. And so, a lot of our users are really like individual consumers, people who are coming from Gmail or Outlook, but the stakes for what we're building are quite high. And so even the past year, we have seen the Russian government banning Skiff because too many of its citizens are using our product. And so, building products that are end-to-end encrypted is a huge part of what we do. It's a huge reason for why people are on our platform. What we found in building end-to-end encrypted products is that it's really deeply linked with building local first software. This comes both at the ideological level and the principles of ownership, security, privacy, but also just in the constraints. End-to-end encryption has forced us to move a lot of our logic into the client. And so we have to do things in a really different way, and a lot of local first technologies have really enabled that. And so across our applications, there are just many different ways in which we've been able to apply local first technologies. I'll go over a couple quickly, and then Guy's going to do a deeper dive on our email product.
Yeah, Jason, we can't see your screen, so it will be hard for me to.
Yeah, if you stop sharing and reshare, my work usually happens for a couple of people.
Can you see it now?
It mainly.
Be able to see. You see the slides now?
It stopped working on mine. Okay, I can see it now. Guy, can you see it?
Not yet. I will give it a minute.
Yeah, were you able to see the previous slides too, or? Let's see.
Okay, how about this, Guy? You have the link, right? I'm assuming You two are in the
Yeah,
same
I can share
workspace.
it.
You can share your own screen and we can keep going once
Okay.
you hand over.
Guy, you want to take over the slides?
Jason, once you stop streaming. Yep.
Yeah, sure.
Sorry about that.
Oh, I need to allow it and reset Discord.
Okay.
Perfect.
Jason, why don't you give us some background about your origin stories in the meantime?
Yeah, in the meantime. Yeah, so I guess maybe to give a little more context on my background, before working on Skiff, I was at Apple working on the Vision Pro team, and that's kind of where a lot of these sort of fears around technologies came. I think the technology for VR and AI is emerging too are really cool. But what it really makes you realize is we're going to spend more time on our devices, and everything is going to be tracked or sensed in a way where you really have to be more conscious of how technology is working. And so, I think it's a really exciting time too, with all the advancements in cryptography, local first software, which we'll talk about. It's really enabled us to do more to protect these things. So, Guy, I think it's on slide 11 if you want to go back a bit.
Yeah, couldn't agree more. And everybody here has a privacy bent in like one shape or another.
Yes.
The biggest one is about like giving users their autonomy and ownership back and being able to work offline. A lot of the principles of local first stem from Ink and Switch, and I did a
Right.
quick survey, and a lot of people share your sentiments. And I can see Guy your slide, so let's hand it over to you.
Perfect. Awesome. Yeah, Guy. So yeah, sorry about the hiccup.
Yeah, Jason, did you finish with your?
No, you should go back to the previous one. So yeah, so as I was mentioning, and as we were just discussing, like there's this really deep connection between local first software and privacy first end-to-end encrypted applications. So across our suite, we see there are places where it wouldn't have been possible to build our product. And so one clear example is with Skiff Pages, our real-time collaborative editor.
People share
The way
their
Skiff
sentiments.
Pages
And I can
works
see
is that all the
Guy, your
collaborators on a
slide,
document
so
have this
let's hand it
shared
over to
symmetric
you.
key that they use to encrypt and decrypt all their edits, and that is encrypted using everyone's public key. And if you use something like an operational transform, you'd need some centralized authority, usually the server, to sort of make those sort of decisions on what is the actual edit. And maybe there are ways that you could, delegate authority to one of your peers, but it introduces all sorts of complexities. And so CRDTs really is this peer-to-peer way of handling these edits and changes that are eventually consistent. Really enabled us to build Skiff Pages. It just wouldn't have been possible. And on the flip side, I think there are a lot of local first technologies that could not really be fully leveraged without end-to-end encryption. So the interplanetary file system is this way of distributing files and data across a network of nodes around the world. And it gives you availability. When one of the nodes goes down, you can always get access to your data. Problem is, if you're uploading, let's say, your photos, even if it's sharded and sent around, you don't want that to be accessible to anyone all over the world. And so on Skiff Drive, we're able to integrate IPFS because we encrypt every file before you ever send it to IPFS. All right, I'll hand it off to Guy.
Hey everyone. So when we started, I'm going to talk a little bit about the mail application we built in Skiff. So when we started to work on it, our goals was first of all to create an amazing experience for the user. We wanted to be like the best mail app out there. We wanted to support people around the world. So for sure, supporting low bandwidth connections and offline mode was very important. We also think that the mail is like the mailbox is like a personal tool that need to be accessible anytime, anywhere. We wanted to have a fast loading and really fluid experience, and at the same time wanted to decrease as much as we can the load on our servers so we can scale easily. As Jason mentioned before, choosing local first architecture was the obvious option for us. We really believe that once you have a really great sync engine, it makes the team and the developers be focused more on creating a great experience for the user and not dealing with network and error handling and other annoying stuff. The big challenge with mail specifically was the type of data. So inbox size compared to calendar app or even a task management app is huge. Just imagine how many thread and emails you get overnight compared to how many events you have for a specific day. I'm going to show a really quick look on very high level look on our sync engine. In the left side we have the client side, and the right side we have the server side. And the client have some state, some items you already fetched from the backend, and you have some cursor, which is like the point in time, the last point in time the client was synced with the server. And each time the client asks for updates, sending over the cursor, then the backend can respond with chunks, thread chunks of items. In our case, we are talking about email threads. And each time the client receives a chunk, the client update the point in time, the cursor. Things can get really complicated when the client have tons of updates from the server to fetch. And I'm going to show some. I'm going to show two issues. One of them is that one, and other we have with the sync engine, with this kind of simple sync engine. So the first one is the overnight updates. You can see the video in the right. The experience can be very jumpy. So user open the app after a while, and the user is actually expecting to see as fast as we can the most updated threads on his list. And because of the sync engine going from bottom to top, the experience can be very jumpy. You can ask yourself why just not in parallel, just asking from the server for the most updated 20 threads. And the problem with doing that is by combining like both sync engine fetching and directly asking for the thread, is that it's creating kind of gaps in the list. So imagine the user start to scroll after we fetch the most updated thread, and then in the middle of scrolling we changing the order, update the list, and the experience is again jumpy. Also, the unread counter is really challenging here, because again, if you have your local state and you fetch the most updated, it's really hard to calculate locally. And imagine it's really annoying to do it offline. So support offline with a counter is really complicated that way. The other problem we deal with was empty state message. So imagine when a user open a folder or label, we cannot be sure if the label is actually empty or the sync engine didn't fetch the data yet. And you need to remember that fetching a lot of updates and a lot of like a huge inbox is hard, but especially when everything is end-to-end encrypted, we also need to take into consideration the time it takes to decrypt the data and show it. And again, the experience is really jumpy. The user opened a folder, we're showing loading indication or empty message, and then something changed, and we wanted to avoid it. We wanted to find a way to be sure when the user opened the folder if it's waiting for something or it's actually empty. And the solution we came up with was to lazy load the data. We created two type of thread. We have the full thread, which is a thread that including all the mails and the attachments. And we also have a slim thread, which is more like a manifest of a thread. It has a pointer for a thread and the critical attributes of the thread, like read and read state and which folder the thread is allocated to. And now the example we talked before, like getting a huge amount of updates becomes really easy, and we can do it very quick because now it's really lightweight, right? I'm asking for threads, and the backend can respond just with the 10 full thread, and the other thread will be slim thread. Also, with this architecture, with this lazy loading kind of combination with fetching to our local database, we can now control the scroll experience. So the user scrolling the list, we are detecting that the user is get close to a gap or a slim thread in our case, and we can directly go to the server and ask for those specific thread. The folder issue is solving because now when the user first time download the app, we can first of all download this manifest. It can be really fast because it's really lightweight, and we can even show some loading state till we getting all the old inbox, and now we can be sure if a folder is empty or not, and the unread count can be calculated locally. I feel like this kind of technique is really common, and it's really cool when it comes to scale or dealing with a lot of data. It also unlocks some cool optimizations, like we can now dynamically remove all threads that we think that the user not going to get to, and actually even control how big the local database is going to be on a specific device, and maybe even let the user define how big he want to how big the memory that he want to allocate to this specific application. Any questions?
Yeah, I think good. I think we can go to the next slide.
We'll do questions at the end, guy.
So yeah, so if you're curious and want to learn more, you can actually view all of our code. We've open sourced everything at Skiff, and today we even announced you can now build our mail front end. We've set up a hosted backend so you can run the whole thing, and so it's a great way to sort of play around and figure out how it works. I have 2 links here on this last slide, but yeah, if you have questions, we'll leave that to the very end. But thank you everyone for taking the time.
All right. So, Guy, if you don't mind, stop sharing. So, I love Skiff because obviously you can see that they're very user centric and they like to give power to the users. 2 things they haven't mentioned: they hit their 1 million user marker. Congratulations on that. And well funded and very profitable company, I would assume. And the next part that is kind of exciting to me is capacity to build aliases. I use my email plus trick on Gmail for a lot of things, but it just doesn't really land well because it's hard to filter on that. And the Skiff way of setting up aliases means that I have a newsletter alias and an app alias, and those will never make it to my inbox. All right, thank you so much, Jason and Guy for that wonderful presentation. Next up, we have James Pierce. I mean, he doesn't need any introduction, but I'll do it anyways. We met last year as I found his talk on user-owned data and making state close to their users. Eventually, we started talking, and then he launched the Bat Signal, which is the webpage most of you saw to get into this community. And now we have him here to tell us about Tinybase and some exciting collaboration. I kind of reversed the order a little bit just in case we have any connection issues, because James is a digital pirate and Matt can take over if we have any issues. So James, take it away.
All right, hopefully everyone can hear me okay. Let me just do my screen here as well. All right, can I have an audio confirmation that you can see the first slide?
Yes, sir.
All right, great. So thank you very much. I think putting me in the middle is a good idea in case we need to come back and have a second go at it. I'm James, very excited to be here and talk to you today. Actually, I'll tell you what I will do maybe, and that is just kill my video to improve the bandwidth. Hopefully you can still see it. So yeah, I'm James, very excited to be here today. I am currently marooned on the south coast of a little Caribbean island called Grenada, where hopefully the internet is good enough for the purposes of this presentation. As some of you might know, I have been writing and talking a lot about local first in general. I had something to do with starting this community, but I will take any opportunity that I can, including this one, to give another heartfelt thanks to Jons for really taking this community and running with it. So thank you, sir, as ever. Today, I wanted to talk specifically about an open source project that I have been working on called Tinybase, because it's really at the heart, I think, of my thinking around local first. As with a lot of things related to the local first concept, the history of Tinybase goes right back to the spinner. So we take these for granted as a fact of online life. When you load the application, when you transition to a new view, when you make a change and wait for the server to reflect it. Basically, whenever you need some data that isn't present on your device. And of course, with a traditional cloud-first app, that is all of it. So my story is this. Several years ago, I was trying to build a client-side app that would provide a detailed analysis of GitHub repos, including the history of follow accounts, issues, pull requests, and so on. Now, all of that data is available via the GitHub APIs, but it's heavily paginated, and for a popular repo, it can take almost hundreds of requests to pull all the data. So I didn't want people to be watching a spinner every time they switched to the tab about a particularly large repo. And I wanted to make the experience as snappy as possible, even for somebody that was using a large repository like React or analyzing the statistics of the Facebook open source program, for example. So obviously the answer was some sort of a cache. And the first choice is to have that cache being in the cloud, obviously otherwise known as a server, to fetch those results and then store them on behalf of the client. But I felt this didn't really come for free. Now I have two code bases. Now I have to worry about storage. I have to worry about scalability. I have to worry about my AWS bill. Now I have to worry about passing around people's credentials. I have to do more gymnastics with the OAuth flows. And I'm sure you've all seen this joke, which is that there are two hard problems in computer science, naming things cache invalidation and off by one errors. Well, ha ha ha, but don't ignore the fact that cache invalidation is one of those problems. And with this architecture, you now have to think about cache invalidation in two places, both the client and the server. So the bottom line was that this just felt like more pain. And was there a way that I could think about this differently? For example, is there a way that I can have structured cache in the app itself? So this app that I was building was a complex enough piece of software in its own right. Why can't it just go that final mile and keep its own data alongside itself? After all, that's what we used to do with thick clients back in the 90s all the time. And I also felt like I was closing the gap between my users and their data, which I came to believe is at the heart of the local first philosophy. But the question was, what did this component need to do? I wanted to have some structure to that data, relational tables perhaps to model the GitHub domain. I wanted a type binding to the user interface. After all, the data is right next to it, so that I could support fast, sub-16 millisecond reactive rendering. It was going to be bundled in the app, so I needed it to be super lightweight. And I also wanted the option for it to be able to persist the data asynchronously, but either locally in the browser or a local file system or up to the cloud when needed. So it turned out that meeting all of these requirements was tricky. I looked a lot. Off-the-shelf state management approaches generally provide reactivity, but they don't provide much in the way of structure. You end up with bits of JSON scattered all over your app, or they just assume that you've got a cloud-first architecture. On the other hand, a fully fledged relational database like SQLite, it's an option, but at least back then, I was going to be compromising on reactivity and on the install footprint. So anyway, given that I couldn't find anything to fulfill these needs, the idea of Tinybase was born. And basically, it's a local first data store and state management library that explores a lot of these ideas and tries to find a way to meet those requirements without too many of the trade-offs. I've been hacking on this for over the last year or so as I've been sailing around on my boat. And of course, it's open source. There's a GitHub repo that you can reach via that URL there. So today is not supposed to be a laundry list of all the features, of course, there's the website for that, but I do want to go through some of the key philosophies and some of the recent community collaboration that I've done with Tinybase, and perhaps a few thoughts for the future as well. So the first thing to know about Tinybase, the clue is obviously in the name, is that it is tiny. And I sort of got a bit obsessive about this, I'll be honest. I took it as a challenge to make sure that Tinybase had no external dependencies whatsoever. So this is quite rare on NPM, as many of you will know if you've ever looked inside your node modules directory. But it's a great perk, actually. You can reason a lot more about your upstream module supply chain and security issues, etc. But what a huge difference that makes to the size. Basically, I have got to a place where all of the major Tinybase functionality comes in at under 9K zipped, and the optional extra integrations, which we will talk about, come in even smaller. The next Tinybase philosophy is that it has a very opinionated data structure. So you have unique named tables containing uniquely named rows, containing uniquely named cells. And a cell can only be a string or a Boolean or a number. And then since version 3, I also let people store flat sets of key values, which are also strings or Booleans or numbers. But that's it. That's all you can do. Now, this structure might seem quite limiting, but unlike a real relational database, these schemas, the schemas for the data are actually optional. And so that means I found I can model most concepts that I need with just these limited two structures. And to work with these structures of data, there's a completely obvious API for setting and getting data in and out of a store. So you set tables, set rows, set cells, or set values, and then you get them back out again. Okay, not very exciting. But I think the next Tinybase philosophy possibly is. So the huge benefit of being opinionated about these data structures is that I can make all of this reactive. And by this, I mean that changes to any part of the data structure can be listened for very atomically, and you can do so at any granularity. So if you register a listener in one part of your app, and then when another part of your app makes changes to the data, you'll get a callback immediately without any pulling or polling, but only for the parts that change. So Tinybase won't waste your app's cycles with parts of the data that stay the same. By the way, this is one of the reasons that you can only store strings, booleans, and numbers. They're fast and extremely easy to check for quality. And binding the data to the UI is where this reactivity really starts to shine. So Tinybase can optionally be used with React, for example, provide a set of hooks and component bindings, and each of these sets up listeners to the data store, which means that your UI components will only re-render when the underlying data changes, and can do so extremely precisely. So, for example, imagine you've built a UI, it's a to-do app, for example, and it's comprised of a table of rows with each to-do in it, showing a piece of text and a done flag for each one. So when a to-do is done, the flag is updated in the database. That automatically fires the event to update just that single component that was listening to just that single cell in the data table. So there's no need to go to a server, no need to render the whole table, no need to even render the whole row. You're literally just rendering that one table cell in the web app. So it's very surgical, and of course it's basically instant. Right, the next philosophy is this. So Tinybase is not a full relational database, but I do try to model what people commonly want to do with one. So, for example, you can define metrics which aggregate together numeric values from across multiple rows. You can set up indexes that let you look up or filter rows that match certain conditions quickly. Or you can create relationships that let you associate a row in one table with rows in another. Unlike an RDBMS, these are also all reactive. So you can listen to, for example, the value of a metric that is calculated from underlying numerical data, And if and only if any of those underlying numbers change sufficiently to update the metric, you'll get the callback for the aggregate. Taking this to an extreme, you can also go all the way and actually express SQL-like queries. So select, where, join, group by, etc., using an imperative JavaScript dialect, and then register your user interface to view the results. And of course, this is also reactive. So you basically have a user interface where the result will change only if one of the underlying dependency rows or cells has changed. So this is pretty wild, to say myself, and unfortunately we don't have much time to discuss it today, but I do think it opens up some really interesting opportunities for local first analytics and many more kind of rich data-driven applications. Talking of which, there are a bunch of demos on the site, all of which are using a local first architecture, and they showcase a lot of these ideas. So I don't have time now to demonstrate them, but you can go and check them out yourself, of course, with all the source code. All right, there's a lot more we could cover too if we had the time. So there are optional schemas you can apply. There is a checkpointing system, so you can have transactions and an automatic undo stack. There is persistence to and from files, browser storage, or the cloud. And recently I launched some inferred and generated TypeScript ORM tools so that you can start modeling your data domain with your TypeScript type definitions. And actually that is pretty fun. But there is one more thing that I do want to talk about, and this leads us on to the community collaborations. So you probably noticed that I talk a lot about data structures, I talk about reactivity, I talk about UI performance and so on. And I think these are all absolutely critical for local first apps. But didn't that feel a little bit unusual? Because to me, it feels like a lot of the local first discussions and discourse we have focuses instead on synchronization and the computer science of CRDTs. So those are definitely valuable topics, to be sure. But for Tinybase, I kind of considered that eventually, or was, or soon will be, a solved problem. And indeed, I think that's now true. So I know this because last month I finally got the chance to really stand on the shoulders of other local first giants. And Tinybase version 4 includes a bidirectional binding to YGS, which is a very well-known CRDT framework. It includes a bidirectional binding to AutoMerge, which is another very well-known CRDT framework. It has a bidirectional binding to SQLite in both the browser with WASM and server environment. And ta-da! It also has a bidirectional binding to CR SQLite, which you'll shortly hear about, I think, from Matt. And so now you can seriously synchronize multiple Tinybase instances together. You simply choose which CRDT approach you want to use, set up the optional binding you need, and then start synchronizing. Here's the obligatory Tinybase synchronization demo. It's the CR SQLite demo that you can clone with Vite and start synchronizing immediately. Basically, I shamelessly forked Matt's existing demo and added Tinybase into it. But seriously, this is a great opportunity to give a huge shout out to both Matt and all of these other local first partners. It's been awesome just working on all these integrations and to see the local first dream start to come alive. And it reminds me that, you know, as a community, we're much stronger working together than trying to reinvent the wheels ourselves. So I'm pretty sure I'm running out of time, but I do want to finish off with a couple of thoughts about the future and cover what I think are some of the interesting problems ahead for Tinybase and perhaps for local first in general. So firstly, authentication and permissions. So I think I'm already echoing what you've heard today and perhaps what you'll hear later as well. But to what degree should identity and authentication be baked into local first state management? It feels like this is increasingly intertwined. what if it's a multi-user device? Like I've just dropped $3,500 on a Vision Pro. I'm probably going to let other members of my family use it. But what if there's local first data being stored on there? Like, how am I going to think about identity? How am I going to think about protecting that data? How am I going to think about privacy? Relatedly, what about sharding? So we've talked about everything being wonderful if the entire data set is on the client, but what if you only have a subset of it? How do you guarantee referential integrity? Or how do you lazy load it? Or how do you synchronize just a slice of the user's data, for example? And by the way, I asked this question before I saw the light threads topic in the previous talk, but I think this is an area which we all need to think about very carefully, because it's not always practical to bring the entire database down in one go. Oops, sorry. This one's a little bit of a left field one, maybe, local first AI. So going out on a bit of a limb, but as you might have noticed, the big developments in large language models, for example, have started to become increasingly open source. And we're now starting to see models gradually emerging and running on the client. And I can run Llama 2 on my laptop, for example. And what can we do as a local first community to help the local first AI movement, or benefit from the shift that seems to be starting to happen over there? There's some cool stuff I'm sure we can help collaborate with or benefit from, and that'd be super fun. But for me, the big one is still this, and I know I'm echoing Jan's and many of the thoughts that we've all had before. Like, I don't think there are yet enough amazing local first apps that we can point to and learn from. Many of us here are building tools and platforms, which I'm sure means we're at an early stage, but I really want to see more people building or helping build actual user applications that showcase all of these concepts and ideals. We need that killer app that we can all hold up as being the kind of the reference application for the local first dream. And honestly, I think we have to step up as a community and lead here to help do that. But anyway, that's me. I'm pretty sure I'm at time now. So thank you very much for all of your time and patience. And I hope this little dive into Tinybase and how it has evolved to be part of the local first stack has been useful. You can find me on Threads. I don't even know how to say the name of Twitter these days. But anyway, I'm on Threads, James G. Pierce, and I'm on GitHub. It's been a pleasure and an honor to be part of this today. And thank you very much.
Awesome talk as always, James. And he dropped a one-liner ad for the tools generation for Tinybase, but for me that has been a big benefit. And what it means is that, let's say you have a complicated JSON-like file of all the data your app state stores. All of a sudden you can just say, now this is a database, give me reactive APIs, and it will be just like there and available. So I have a get application feed as a function that got created without me writing a single line of code. And I have add feed as a function also generated that I didn't have to write. So I'm a consumer of Tinybase, big fan. I like to say I was early, but I got in on version 3, so others can claim even bigger OG status.
Well,
but love everything you're doing. Keep up the hard work.
You were one of the first. You're
nice.
Definitely one of the first, which I also want to thank you.
Nice. And the AI, local AI, is something that I'm really passionate about. Given how invasive all software applications are, we need a competitive product that doesn't have the privacy barrier. So if something is local to me and there's no backend, I'd be happy to give that AI my messages, my GPS, my bank account, as long as it doesn't talk to anybody about it. So that's a future that I envision where deep context on users can be leveraged for really beautiful product experiences that are being blocked by this adversarial relationship where you don't want to give more data, but you want the product benefits, and you just keep pushing the boundary over and over. But enough preaching. Now we have, as James introduced, Matt is coming up on stage to talk to us about the next frontier of local first apps, beyond CRDT. Accept the call and build apps on top of these giants. And I'll just hand it over to Matt to give us a wonderful talk. I think you might be muted, Matt. Or you're not muted. Yes, you are.
Okay.
There
Cool.
you
Let me start. And you can see the slides?
go. Yep.
Cool. So yeah, I'm going to talk about beyond merging, the next frontier of problems for local first software. A quick intro about myself. So I'm Matt. I started building a tool called CR SQLite, which adds eventual consistency and CRDTs to SQLite. So the idea is you can have a database, I can have a database. We can make changes independently, then we can merge the two. And since lots of apps are backed by SQLite, this kind of gives developers a way to create collaborative apps by default. But a quick reminder about local first is that like local first doesn't mean local only, right? Like, yes, we want data on device, but we want to be able to also collaborate across devices or sync with other users. So there's still a network component to local first. And given that data is on device and we're going to merge with other users, a lot of the research and focus in the local first community has been on how do we solve this merging problem. But today I want us to just sit back for a second and just imagine that merging is completely solved, that you save a file, it gets synced everywhere it needs to go, everybody gets the updates, and everything works as intended and expected. But even in this world where like things sync perfectly, there's still some stuff that's lacking. And the most obvious problem is partial sharing. So if you think about cloud-based applications, they really raised the bar on user expectations with respect to sharing. So if you have a document in a cloud app or repository, you can share a single item, right? I can share a single playlist or a single track from a music library. If I'm using a task tracker, I can just share the tasks I've assigned to people rather than my entire document of tasks. Or a presentation, right? I can share the presentation with you, but not my speaker notes. And same thing for write protections, right? Like I can maybe add you to a Airtable spreadsheet, but not let you edit certain rows because I haven't given you permission to those rows. Or I can add you to a document, but not let you edit the document, you can only comment. So there's a couple solutions to partial sharing. The first two I'm not so keen on, but I'll go over them. And then there's two more, which I think are the right way to solve the problem. So the first one is like implementing rules in the client. The second is encrypting subsections of the document. So in this world where you have client-side rules, you basically have a document, maybe like you have a spreadsheet and all the data is in there, but you have certain rows you don't want people to see. So you have an ACL that says, viewer Tom cannot see these rows. And then the software that renders the spreadsheet is responsible for hiding these rows. Obviously, that's not great because all the data is there in the clear. Anybody with some technical savvy could just pull the data out that they were never supposed to have access to in the first place. The next option would be encrypted sections. So maybe each section of the document that you think should have different permissions, you encrypt with a key. So when I share my documents to you, maybe I don't give you all the keys, so you can't see certain sections of my documents. And if you want access, maybe you go to a key service and you can get the key that I've given you access to. But I don't think either of these are good enough, not for their technical limitations, but for other product features or user expectations. So the two main things that are wrong are if you want to share a document, like if somebody wants access to a subset of the document, they need to get the entire document. And this is a problem if documents are really large. And the other issue is transclusion. So this is the idea of including one document inside of another and being able to see changes reflected in both. So imagine I have a spreadsheet that I use to track my work life, my tasks, my meetings, whatever is happening. And somebody else also has a spreadsheet that they're using. And maybe in their spreadsheet, they assign me tasks to work on. Well, if we don't have transclusion, they have to send me their spreadsheet. I have to open it just to see the tasks they've given me. In an ideal world, when they assign me tasks, well, sure, they're working their own spreadsheet, but the tasks they assign me should come out of their document into my document, and I should be able to work them there in my own context. And if I complete these tasks, I can update the status, and that status should be reflected back into the originating spreadsheet. And this is very common in cloud-based applications. So in local first, I think we can solve this in two different ways. One is document slicing, and the other is document atomization. So in document slicing, essentially you have your document, maybe your music library or your spreadsheet or your task list or whatever, and you have queries that specify subsets of the document that you can slice out and share with other users. And permissions are handled by, you add people in to be able to see the results of a query or be able to write to the data returned by the results of a query. And permissions are checked on, for read permissions are checked on send. So if I'm sharing something, if you want to pull from my database or from my document, it'll run the query for the section and check, oh, did you have access to that query before it sends you the data? And write permissions are checked on receive. So you can hack your doc all you want, change the permissions all you want, but my permissions are still what I set up. So if you send me data that I didn't want you to overwrite, they'll be rejected. I think one problem with this is like it's complex to reason about privacy made against queries. So if you think about like web apps and controller level privacy, if you put your privacy or permissions at the controller level, and then fast forward a few years later, your product has evolved and made changes. Now that controller that was correctly permissioned is returning new data, and suddenly you have a leak. So you want your permissions as close to the data as possible. So that brings us to the second option, or the last option, which is document atomization. So the idea here is rather than having a single doc, like a single music library or a single task list doc, you atomize it to every piece that's possibly shareable becomes its own document. And each document has its own permissions, which means permissions are close to the data. So an example of this, say you have a case file on a patient that you have, and you have evidence for like what the diagnosis might be. You have comments made by the doctor, you have correspondence with patients. All this is part of the case file, but people have different permissions of what they should be able to see. Like a patient can see their correspondence, a doctor can see everything, maybe a specialist can only see the evidence, and so on. So these should be separate documents so they can be shared independently. But that brings a different problem. Like there's just so many documents, right? How do you deal with this, I don't know, proliferation of documents and manage them all? So I think when you take atomization and slicing together and you kind of look at them, it turns out it's really a database problem. And I feel like everything is actually a database problem. So what we can do here is kind of model our documents as databases and at whatever granularity you want. So you can have a database per file, whether that's if you're building a PowerPoint app, it maybe each presentation is its own database, or a database per user. So if it's a presentation app, all the data is in the same, sorry, I think I got, all the data is in the same user database. And the reason this works at any granularity is because the database has expressivity to query for slices of the data. And it's also fulfills the property as atomization, because if the database is fully normalized, you have rows for each logical unit of data, and you can put security policies on those individual rows. But like, how do you set this up? Well, in this sort of situation, you would have databases could add other DBs as remotes, kind of like Git. You have a Git repository, you add other Git repositories as remotes that you can push and pull from. Except here, when you're pushing and pulling between databases, you're pushing and pulling based on queries of slices of data you want. And you're transcoding into your database or other people's databases. And you can also set this up in a centralized fashion. If you do it in a centralized manner, then you know the privacy rules are centrally managed and never changed. So that'd be good for like organizations or companies. And sharing, so I said you could share by queries, but you could also just share like, oh, I'm going to sync the entire database, but before sending the rows, just apply the read filter or the write filter. Yeah, and some practical examples of this. Yeah, imagine you're a DJ doing a show in a club and you want it to somehow be collaborative. You could ask all the club attendees to like share a playlist from their music library to you. That gets transcoded into the DJ's music library, and then he can mix some new set for everybody. But this is, so yeah, partial sharing is just one issue. I don't have time to get into the rest, but we'll briefly touch on another, which I think was touched on actually by the previous two presentations. And the other is tiered storage. So in local first, in cloud first, we don't really worry about storage at all, right? You just like open your app and you have access to all the data that ever was there, so long as you have internet. In local first, we're trying to move data to the device, but people have devices of different storage capacities. So obviously you can't really move all the data to the device. You need to somehow have it tiered where like some data is on your desktop, some data is on your tablet, some or wherever, maybe some's in the cloud. So I haven't fully come up with like good paths for solutions here, but I guess one principle is like try not to be magical. So like databases, they do solve this paging problem, right, between memory and disk, where you query some data, it pages it into memory, and when it's no longer needed, it puts it back on disk. But I think like it's okay for the database to solve it at that level, because the failure mode of if the database gets it wrong, okay, your query is a bit longer. But if the database gets, or framework, or whatever you're using, gets the paging wrong from disk to cloud, then the failure mode is you go offline and suddenly the docs you thought you had access to are not on your device and you can't edit it. So the failure mode is much worse. So I think the main guiding principle here is like we need to provide explicit APIs for the developer to control what gets hydrated where and how much, so they can create the correct experience for their application. And beyond these, I think these are two biggest problems, but there's also auth, schema evolution. I think those two are actually really easy to solve if you make a few simplifying assumptions. And then there's mix. The last one is like mixed consistency needs in the same app. Like not everything needs to be causally consistent. Some need strong consistency. Some things you might just want to treat as a cache and always pull from some sort of server. And yeah, that's it for me.
Awesome talk, Matt. For those who are paying attention, you can see that Matt spent a lot of time trying to think through all the cases in which synchronization, local first data storage, and all of that. As a consumer of these things, I'm sort of always intimidated watching how much effort the layers for storage and sync are putting in. But at a high level, my interests are to plug something in and build my product, and then have that be able to synchronize across many devices the user owns. And then one step is live collaboration where multiple users, multiple devices. That one sentence has so many ramifications that this community has helped me understand. And I'm grateful to all you giants building in this space. So that's the end of our presentations. What we will do now is open it up for questions, and recording and streaming are now going to be shut